My name is Kevin Rushforth, and this is the Java Packaging Tool Talk, or jpackage as the tool is going to be known. So we'll have sort of a little introduction on jpackage. Why do we need it? So I want to motivate why we're putting this tool into the JDK itself. What some of the features are, I'm going to show several demos, and then give a status update on where we are and where we're going in the future. And I hope to leave some time for questions at the end. So if you have any, save them up for the end, and we'll get to them if we can. So first of all, just a simple, brief overview of jpackage. It's targeted for developers, not for end users. So it's another tool along with jar, JImage, JMod, and Jlink that allow you to take your program and the JDK and build something with it. In this case, building a standalone application is the goal of jpackage. Not only building a standalone application, but being able to package it up in a way that you can deliver it to your end users such that it will both be a natural installation experience and that it will integrate well with the native operating system. So the input to jpackage is a pre-built application. And that's usually in one of two formats. It's either one or more standard class path jar files. So this is for a non-modular application. You'll have it in one or more jar files, along with some resources that you might have that are outside your jar files. And the other option for your application is a modular application. And that can also be in one or more modular jars, or you can use JMods if you happen to have native code in your application. Those are the two forms an application can take, and then it also takes a Java runtime. By default, it uses the Java runtime from which you run jpackage. The support we provide with it is for Mac, Windows, and Linux, so we have integrated support for all three and for different package types on all three. And the end goal is to provide a straightforward way for your end users to install their application in a way they're familiar with and that interoperates with the native machine in the way that they're familiar with for that machine. We're defining this by JEP 343. And now we'll get into why do we need it. So in the old days, where old days is JDK up to and including JDK 8, we also had it for JDK 9 and 10, but those releases have stopped shipping. And now we have JDK 11, which is different. But in the old days, we used to have a shared system JRE that first Sun and then Oracle, sometimes working with OEMs, laptop manufacturers, would try to get the JRE to be on as many machines as we could possibly get it on. The benefit that gave you is that you could then run applets in a browser or Java Web Start applications on your desktop just by delivering a platform-independent jar file and then have it run as an applet in your browser. Well, browser manufacturers are getting rid of that first option anyway. There's only, I think, one browser left that consistently supports applets, and that's Internet Explorer. And when that goes away, applets go away. The other thing that we did with that system shared JRE is that, again, first Sun and now Oracle continued to auto-update that. So every 3 months, we would push out a quarterly release that consisted primarily of security fixes, but also of other improvements like new platform support. When a new version of Mac comes out, invariably something breaks. When a new version of Ubuntu Linux comes out, same thing. When Windows 10 came out, same thing. And so those quarterly updates also contained those sorts of improvements. The deployment of apps in this model was very convenient for application developers. But it did come with the cost of a shared JRE that is becoming increasingly difficult to maintain. The Web Start apps didn't integrate particularly well with the desktop. You might get a desktop shortcut, but that's all you would get. You would never get file associations. The installation experience wasn't what people were familiar with. We had to provide a Java control panel to do that, to be able to manage your application to uninstall it if you needed to. And so for desktop, some applications ended up using the system JRE. Some applications ended up bundling their own with some other third-party solution or used install4j or ended up using Install Shield or Wix themselves. And as of JDK 11, that's really the only choice that you have, because the shared auto-updated Java runtime is gone. That's not part of the JRE. It's not likely to come back. And Java Web Start and applets are also gone. And even if they weren't, they're really incomplete without that first solution. Because if you can't rely on the fact that there's a Java runtime on there, you've got to get the user to put a runtime anyway. And so in the new deployment model, which actually fits very well with what Apple and Google and others are doing with their app stores, is that you bundle up everything into a single self-contained application. And so that would be your Java application, the JRE, any other resources you might need. Bundle it up into an installer and ship that to your end users. So jpackage does this, and it does it by running Jlink to create the runtime. It includes your application if it's a modular jar. And you also have the ability to run Jlink yourself if you need more customization than what jpackage provides when it runs Jlink. So let's take a brief detour on Jlink. So how many of you are familiar with Jlink? I'm trying to figure out how much detail I should go into. So I'll at least give a good overview of it then, since it seems like some of you are, but not everyone. So what Jlink does is it takes the existing runtime that you're running with, and it builds a new runtime. And you can customize it in any number of different ways. You can add modules to it, either your application or a third-party library. You can exclude modules from it. For example, if you're building an application that's a runtime, you probably don't need the compiler. You don't need JavaDoc as a tool to be there. And you may not need any of a number of other ancillary modules. If you're not running an XML parsing engine, you probably don't need the XML parsing classes. Similar to that, if you're not doing a desktop application, you don't need java.desktop. What it then does is it creates a new JDK. So it will take the existing JDK, add some stuff, remove some stuff, and create a new JDK over here. That JDK is now something that you can use to run your application. If your application was modular, it might even already include your application. But it's not an installable bundle. It's still a file system layout that looks just like the JDK. So what then? So as I mentioned earlier, today's Java developers are stuck either using their own custom code with whatever packaging system the native tools give you, like Wix, or you could use the Xcode installers for Mac. But you have to write a lot of your own custom code to do that, or you use a various third-party tools, one of the ones that's out there. So as I mentioned, Jlink is used with jpackage to create the custom runtime. jpackage, though, will run Jlink for you in most cases. And most of the examples that I'm going to show you will be having jpackage run it for you. Because what we think is for most applications, unless you really need to customize your JDK, then you can use jpackage and have it run Jlink because it's much easier for you. But in case you need to do it, just a quick, brief tutorial about Jlink, just a one-slide version, if you will. The first one is the simplest one. That creates a very small JDK that only includes java.base. Java.base, if you're aware of it, is the module that contains java.lang, java.util, and a few other things, but most of the things that could be optional that aren't needed to run a minimal hello world program are not part of java.base. So this would be a very small runtime. It probably wouldn't do what most applications need, but it's the simplest example. The next one is the same thing, only it includes java.desktop and java.data transfer. Those implicitly also include java.base, and so you'll get one with, in this case, I think 3 modules is all that will come with. There may be one other, because what Jlink does is it takes the list of of modules that you put on the command line when you say add modules, and it uses just those modules plus the transitive closure of what those modules themselves depend on. So everything depends on java.base implicitly, so you'll always get that one. You don't need to specify it unless it's the only one you want. And the last one adds some additional modules. In this case, let's pretend that I have a module called mymod, and it says in addition to that jar file, which contains my module, and that module, it'll pick its transitive dependencies. And I don't want man pages, header files, or native commands. I don't need the Java launcher. I don't need any of these other things. And so you'll have a custom runtime without any of that. So let's go back to jpackage for a little bit. By way of background, we used to ship a tool with JDK 8 called Java Packager. only we used to ship that just with Oracle's JDK 8. It was never part of OpenJDK. It was actually delivered and developed as part of JavaFX. So even though it was started out as FX specific, and even when it became JavaPackage or had some FX knowledge to it, it became general purpose enough that we changed the name to Java Packager and then made that available to package any number of different kinds of applications, but only if you had Oracle's JDK. Well, in JDK 11, we removed JavaFX, and thus Java Packager was removed as well. And since it was never part of OpenJDK, it's something that we now need to bring back in. And so jpackage is based on Java Packager. To give us a head start, we took a lot of the, not only the concepts of it, but we took a lot of the initial source, cleaned it up a fair bit, removed anything that was WebStart specific, applet specific, or JavaFX specific. Although, as you'll see later, it can still run and package JavaFX applications. But there's no special magic or special knowledge of JavaFX inside jpackage anymore. And then we also had to exclude a few other versions, a few other features from the initial version that people are used to. So the ones in that last sub-bullet, the user JVM options, service daemon, and single instance support, those might come back in a future version. The other removed stuff won't, because it's not really appropriate for a JDK tool like jpackage. So jpackage can be used to package either desktop apps or command line apps. And I'll show an example of, I probably won't run a command line app unless we have a little extra time, but I'll show how you would do that. It will create the application image for you, and by that I mean it will take your JDK, it will take any extra modules you need, exclude what you need, and produce the JDK that it will end up using. And then it will package that along with your application jar files, other application resources, and it will create launchers for you, and it'll create configure files so that it can pass arguments to the Java runtime machine and to your application. And it puts that in a directory structure. Now, normally that's a temporary directory that's just used as input to the create me an installable package step. But if you want to, you can actually save that and use that for whatever you need. By default, it creates the package format for your specific machine. If you're running on a Linux machine, it will create either an RPM if you're a Red Hat-based Linux, or a deb file if you're a Debian-based Linux like Ubuntu. On Mac, it will create either a DMG or a PKG. DMG is the default. And on Windows, it will create an EXE, which is the default, or it will create just an MSI installer, whichever you want it to do. So jpackage can be invoked either from the command line, and we expect that's how most people will do it. But if you want to integrate it in with Maven or Gradle or Ant or anything else, any other, like an IDE, you would want to be able to call this from Java. And so just as with any other tool like Jlink or JavaC, you can invoke it via the tool provider API. And you can specify, and I'll show an example of that, the JDK and application arguments that you want used when you run your application. That way you can ship this installable application, have a user double click on it, and you've already specified what the heap size is, what other application or JVM arguments you have, in anything you want. And I'll show an example of doing that with a splash screen. So the packages that jpackage produce will integrate with the native platform, and some of the ways it does that are fairly obvious for applications wanting to do that. We can set file associations. So if you ship an XYZ tool application, then you might want, when you double click on an XYZ file, for it to launch your application. Well, that's what this will allow you to do. It will create a desktop shortcut for you, or put it in the file menu, and those are all options. You can either have it do that or not. That's up to you as the application developer. You can create multiple launchers so that if you have an application that has multiple entry points, or maybe even a single entry point, but you specify different arguments to your application, you can create two launchers so that you can double click either one and you'll get the correct behavior that you expect for those two different entry points. We have some required tools that we use. We don't provide any of the support needed to directly create an MSI file. We rely on the user having installed Wix tools, which Microsoft also recommends. Likewise on Linux, we assume you're just going to install either RPM util if you're on a Red Hat machine, or dpackage and fake root if you're on a Debian. It's basically the same things that you'd have to do if you were creating your own packages on there. That's what we use, and we piggyback off those. For macOS, all we need is the Xcode command line tools. So just as important as what it does, what does jpackage not do? So it's a very important part of the puzzle, but it's not the whole end-to-end, develop your application, point jpackage at it, and now you have a complete solution, including an app store and a website. It doesn't do that part of it. What it does is it creates native packages that you can then host on your website to deliver it to the end user. There isn't any cross-compilation support. Referring back to the previous slide, because you have to have Wix toolset, you've got to run it on a Windows machine. If you want a GMG file, you have to have the Mac Xcode tools. It has to be run on a Mac. And the JDK itself from which you run this and which is used as input to this also, when you download it, you download a JDK for Mac, Windows, or Linux. And so if you need to deploy on all three, you're going to have to build it on all three. The other thing it doesn't do is support JNLP, but we hope to ease that by providing a demo program. We already have a first cut at this, a JNLP converter, that will take your application's JNLP file and your resources, the jar file and other resources that you have, and it'll call jpackage to produce a packaged image. And the important thing is this is a demo tool. It will help get you most of the way there. For simple things, it'll just work. For other things, it will give you a head start. So now I want to get into some of the demo cases, and I'll spend a fair bit of time, especially on the first couple of slides, and then just highlight what's different for each of them. At the end, once I finish that, I'll run several demos of this. So the first one, the main thing I want to call your attention to is basically all of the arguments, but the pieces that are in red are the platform-specific arguments, in this case for Windows. So we specify a package type. And by way of note, we've just agreed we're going to shorten that to --type to make it easier. We already know it's a JPackage, so it's redundant to specify package again. That tells it that it will do an exe. I actually could have left that one off, but I wanted to show it on the slide just to show you what you can specify as an option. The reason I could have left that off is because on Windows, that's the default. Likewise, you then specify a name. That's one of the, I think, 2 or 3 required parameters that you have to have. So you have to tell it what you're going to name your application. You can optionally give it a description, a vendor, and a version. It's recommended to give a version because you'll want to be able to, as an application developer, ship new versions and then have update rules, know about upgrade and downgrade scenarios. And so it'll support that. You tell it where to put your input, or where to take your input from. In this case, the input directory just has a jar file and a splash screen PNG file. And you can optionally tell it where to put the output. If you don't tell it, it'll just put it in the current directory. And since it's just a single .exe file, that's usually fine. If it's an app image, it'll create a directory with the name of your application. So either way, it's a reasonable thing to do to put it in the default. But I wanted to put everything in the output directory just for consistency. And then you tell it what your main jar file is. This is in the case of a normal, non-modular application that runs on the class path. And then I can specify Java options. This is something that's optional, but I wanted to tell it to load a splash screen. So I actually tell it, when you launch swingset2_demo, run the JVM with --splash:\. $aptor/splash.png. Now, $aptor is a special token understood by jpackage, and it expands that to wherever the application gets installed, because on different platforms, it will be in different places. On Linux, by default, it goes into /opt. On Windows, by default, it goes into C:\program files. And on Mac, it goes into /applications. Plus, then you don't have to worry if we change the layout underneath that, because it actually is in a different place on Linux than on Windows. And so you don't have to know about that. All you have to know is, well, I know where my resources are going, so I can just say $aptor/splash.png, and as long as my input directory has a splash.png file, it'll get copied to the right place, and it'll run. And I'll show an example of that. And then the last option, which is Windows specific, is I'm telling it to create a Windows shortcut. That's a desktop shortcut, and to put it on the start menu. So example 2 is really the same example as the first one. I'm just using the tool provider. So this is the standard API, the java.util.spi.tool provider, and you pass in the name jpackage, and it will return you an instance of the jpackage tool. And then we use that instance to call the run method, and what's passed into there besides the system.out and system.error, you just have to tell it where to put your standard out and standard error, is the exact same list of arguments we had in our shell script when we ran it from the command line. And it works the same way, and you get the same result. So this is, again, mostly for tooling integration, but we think it's an important integration step. This example shows another standard non-modular class path application, but this time with some additional libraries. I picked one that's near and dear to my heart, which is JavaFX. And what we've done here is we've taken one of the example programs for JavaFX called Ensemble, and we've created a jar file from that. So that was done outside as normal step. You run javac, you package it up with jar, and now I have ensemble8.jar. And the part in green is the part that's different for modular applications. And that's that we specify where to find these additional modules, the JavaFX modules. And then we use --add modules, which is also, it uses the same syntax as Jlink or Java or javac. It just tells you these are some modules that we're going to run. And in this case, those are the 4 modules that we need for our application. And this is the same example as the previous, but it has a library and a modular application. So in this case, everything gets compiled. In the previous example, the JavaFX, let me go back to that just for a quick minute. In this example, the JavaFX modules get linked in with a custom runtime that jpackage produces when it calls Jlink. But ensemble.jar just gets copied into the app directory as ensemble.jar, unmodified. And then it gets run on the class path, whereas the FX modules are run as part of the runtime. In this example, the application itself is linked in to the custom runtime that jpackage calls Jlink to produce. And your application is no longer in a jar file, it's part of the Java runtime. And so what you would do after that is just double-click on it, and the only thing that's there is your runtime. There's no additional jar file, no additional resources, unless you need something outside your module to run, which you can still do. So you can still have a splash screen file or anything else. But in this example, input contains a modular jar file called mandelbrot.jar, and I'm telling it when it launches, that last line there, the module mandelbrot/demo.parallel.main, is saying to run the main application in the Mandelbrot module with the class name of demo.parallel.main. And so that gets launched. And I'll show an example of that as well when we run it. So as I mentioned, you can run Jlink yourself if there's some reason that you want to customize it yourself. Now, in this case, I'm not really doing much customization beyond what you could do just by having jpackage run it, but I wanted to show an example of running Jlink. So this would generate roughly the same thing the previous one would generate. And that's that I'm generating a custom JDK that includes the FX modules. And I might want to use that for other things. So that might be another reason I do this once, because I might now have my JDK that includes JavaFX and can be used for any number of applications. And then I run jpackage with all the same arguments as before, except that I say --runtime image JDK14 plus FX. So what that does is that says, don't use the Java runtime that I'm running jpackage from as the starting point. Use this custom runtime over here that I've already run Jlink on. And you can use that also to run different versions. It doesn't even have to be a Java 14. And in fact, this is an example of that one. Let's say that you want to use JDK 11 LTS because you like using a standard supported stable version rather than wanting to rev to JDK 14 to JDK 15, 16, 17 every 6 months when they come out. You can do that because even though we don't have jpackage into JDK 11, and it's not going to go back into OpenJDK 11 likely, or if it does, it'll be sometime in the future. But you might want to package your application with that. So for this example, I've created a program called JDK 11 version demo. I made sure to compile that jar file with JDK 11 because otherwise it won't run with JDK 11. And then the only thing I'm doing different from previous examples is I'm specifying -- runtime image JDK 11.0.5. And this is an example of a console app, which I won't actually run, but it shows you what you end up doing is we are creating a console app and we use -- win_console. So this is for something, and we don't use shortcut and menu, because all we want is a simple command line based tool. It might be something you would put in a daemon or the Windows at startup time or any other reason you might want. Or it might be, for not for Windows, but for Linux, you might want a command line tool to run. So it doesn't have to be a desktop app. Okay, so now I'm going to run a few demos. Let me get this out of the way. I'll get that out of the way too. So let me make sure that's visible. Yeah, that looks like that's reasonably visible. So the first demo I'm going to run is the Swingset demo. And so if you look there, that will be exactly the same set of arguments that I showed on that first slide. And so we can see we're creating an exe package. We're calling it Swingset2 demo, and we're giving it all these options. And that should be done soon, and then I will... Okay. And so then that puts it in the output directory when done. Let me make sure that... Yeah, that's... Okay. So there we have it. And so now when I double-click on that, I didn't sign this. You're going to want to sign this if you distribute this. And if I were really going to distribute this to anybody, I would. So that's why I get a scary dialogue, because I am an unknown publisher. I guess they've never heard of Duke Enterprises, and I didn't buy a certificate, so I guess that's what I'm stuck with. But once it installs that, you'll see the application icon there on the desktop. And you'll see it right here in the menu. So I can run it from either one. And you'll notice the splash screen came up. You might also notice that it came up and then changed size. That's unrelated to jpackage. That's actually a bug with high DPI and splash screens. And so you just double-click it. So either way you run it, you get the same application. And this is just the standard Swingset2 demo that you may have already seen before. So I wanted to show you the layout. I hope you can see that. Let's see. Oh, yeah. So that's what gets stored in C:\program files. It puts it in Swingset2 demo. And then you have an exe file, which is the double-clickable application that you can run. And then there's two directories. Oh, then there's the icon, which is that by default Duke icon. You can supply your own icon if you want, if you have your own application logo. And then inside the runtime directory is the JDK. And so I actually might go show you what I'll do that later for a different one. And then in the app directory, we have the original application. That was the one I provided in my input directory as the application non-modular jar file. And then we create a CFG file. That's a configuration file, and that's where we put in all of the information that jpackage needs to know to launch your application. So all of your Java runtime arguments and other things that we need to find and launch your app. And then splash.png, which is the screen, splash screen that we saw. So that's that one. And now we're going to run the ensemble application. And actually, while that's running, I think I will. So inside there, the runtime directory, I hope you can see that all right. Yeah. So we've got a release file which contains all the modules. So you'll see this one has just a whole boatload of modules because I didn't specify anything about trimming down the modules. We're looking at ways to even make it by default trim it down, but if you specify your own set of modules, it will trim down the list, and you'll see that in a second here with... so you don't necessarily have to run Jlink to get it to do that. So now we'll go ahead and install... Oops, wrong one. So we'll go ahead and install the Ensemble app. And again, it's both on the desktop as an icon and in the Windows Start menu. And so this is a JavaFX application. And now if we go into you can see a much, much smaller list of modules. It only has a few things from the core right there that it needs, and then a few others, and then the JavaFX module. So that's a much shorter list, and that's what you can do with Jlink, either if you run it yourself or if you run jpackage and tell it what modules you want. It's only going to use those modules and the transitive closure. So you can really get a much smaller JDK image, which is a nice thing for your application. All right, the next demo, I'm going to skip the modular JavaFX app in the interest of time, because all that is it's the same thing, but just with a modular app. This is one I want to run and show you. This is the one that uses JDK 11. And so we have JDK 11. While that's running, I'm going to actually run the application. So I created this as an application jar file. And if you look in input, assuming you get the colors right, if we look in input, you'll see there's a JDK version.jar. Well, I'm now going to run that with the same JDK. Let me just make sure I'm doing it with the right JDK. This is with the same JDK I used to package the app up. And so what this does is it just pops up a little window with a label that says what JDK you're running. Well, in this case, I'm running it with 14-jpackage. So it's a jpackage early access build of 14. And that's because I just ran the jar file. I'm not running what I packaged. But now that this is done, when I go into the application and install it, that installable application was built bundled with JDK 11. And so now when I run this, it's going to say 11.0.5. And there it is, 11.0.5 plus 10 LTS. And so that's how you would package it up with your own custom runtime. And I think that's probably all I'll show for now. And then I'll show a couple of demos also on the Mac in a bit. Okay, so the Mac is pretty similar, and again, I've highlighted the Mac-specific commands. We only have the one in this case, and that's to specify the package type. As I mentioned earlier, DMG is optional, so in this case, we really did have to specify that we wanted a PKG installer. All of the other options are the same. So this is the same Swingset demo that we ran before, only as a PKG installer. And then I have Ensemble 8, which is the same example we saw on Windows, as a DMG file. And so otherwise this is identical, so I just removed the Windows-specific options, the Win shortcut and Win desktop, and I changed the package type to DMG, and now exactly that same script will run and build a Mac application. Similarly, we can create modular FX and modular, in this case, Swing applications. And you'll notice again, when we use module path, we specify that it needs, the input directory is now for the module path, and we tell it what module we need. So the only module we're giving it is our application. And because it's a modular application, its module info tells Jlink and Java what modules it depends on. And so Jlink, as called by jpackage, will package up all the modules that Notepad depends on. But we also added a couple of other ones explicitly in this case. I believe those last two, though, were not needed. And then this is the same example, only done with a custom runtime. And then we have the same JDK 11 application, only run as a DMG. And so now I'll show you just a couple of demos on this, and then we'll get back to the slides. All right. Okay, can you see that all okay? Yeah, it looks like that should be visible. So I only want to run a couple of these. So this one, again, is the same as we looked at on the slide. We're telling it, create a package of type PKG and bundle up swingset2.jar. And I think it runs a little quicker on Mac than it does on Windows. And since this is a PKG file, it's going to install it with system permission. So I have to type my password here. And it said it was successful. So now I've got the application here, which I guess you can see that on the screen. But if I double-click it, you'll notice that it runs. Mac doesn't have the bug with high DPI and splash screen, but it runs the same way as it does on Windows. It creates a double-clickable application that feels like any other Mac application. It shows up in your application menu. When you double-click it, you get an icon on the toolbar. Everything just feels like a normal application. And the only reason you know it's Java is because in this example, I let it do the normal Duke logo, which is the default one. Sorry, the default Duke icon. Let's see. All right, I think I do want to show this one, and then I'll skip the last one. So this one is the same example that we ran on Windows. This is using and bundling up a runtime from JDK 11.0.5. And in this case, it's creating a DMG rather than a PKG. So now when I open it up, oops, that was the wrong one. Open output. We'll do that one instead. And so now it opens up and launches the DMG file, and it gives you this. Yeah, that was from my earlier mistype. And it gives you this where you can drag the application to the application folder like people are used to seeing in a DMG file. And then we can eject that, and now we have JDK 11 version demo, and it comes up and runs the same way. And it says that we are 11.0.5 LTS. So. Okay, so now we'll get back to doing this on my Windows machine, but I actually want to show you a couple of examples on Linux. So in this case, there's a few more things listed in red that are Linux specific that we specify. If you're on a Debian-based machine like Ubuntu and all you have, you don't have to, and if you haven't installed the RPM tools, you don't need to specify the package type. It's going to go detect that you're running on a Debian machine, and it's going to produce a Debian package. But I put it here explicitly anyway. The rest of this is the same Swingset 2 demo that you're used to and that we saw before. And then we specify a few Linux-specific options like the Linux package name, because I wanted it to conform to more natural conventions. I didn't want it to be mixed case with Swingset and an underscore in there, because it will default to the application name, but I wanted a different package name. And then I can specify the Linux Debian maintainer and the app category that it's going to go into. And I just put this in MISC because I didn't know where to put it. And then on Red Hat, either an Oracle Linux-based or Red Hat system, those are both using RPMs. It's the same thing, except I specified package type RPM. As with the Debian, if all you are is running it on a standard RPM and you haven't gone and installed dpackage manually for some reason, you don't need to specify the package. It'll figure it out for you, the package type, I mean. And so now, if this works, I hope this works, we're going to run just a really quick example on Debian Linux. And So we'll go ahead and do that. I'll just show you a very quick example on Debian Linux. And so what we have here is the Debian package manager, the application manager on Ubuntu. This is just an Ubuntu 19.10 machine. And it's got the same application as we had before. So I'm running exactly what we just saw on the slide. And it's going to create a .deb file. You can install it with jpackage directly. I'm going to show you installing it just by using the package manager and double-clicking on it. And so now I'm going to find here. It should be done pretty soon. And I want to wait till this finishes just to make sure that it's actually done. Yeah, this should be finished by now. Let me see if it is. And it just somehow didn't. Nope. Looks like it's not quite done. Well, if this doesn't come, oh, there it goes. Okay, so I'm going to go back to that and double-click on it again. Now that it's finished, it should come up and install. So it'll bring up this install icon, and I just click install. And I don't think I said to put an icon on the desktop, but it will be available in the application window here. So if I go back to the main window, let's see, I want to go to installed. And you'll see it down here in the add-ons. I guess that's where it puts MISC programs. And I can just double-click on it there and remove it if I want to, or I can go to this one and run it. So you can see it's in /opt/swingset, and I go into the bin directory and I run it. Okay, that's probably good enough for now. Okay, so we'll go back to the slide. So just to wrap up, the status of jpackage is right now we have early access builds of a branch in the sandbox. So we have an OpenJDK sandbox that we've been producing early access builds. It's available from jdk.java.net/jpackage. And our plan is to deliver it in an incubator module in JDK 14. Now the reason we're doing that, the reason that we're delivering it as an incubating tool is because we don't feel we've gotten enough feedback. Every time we put out an early access release, one or two more people come and say, hey, I'd like to try that. And we get a little more feedback and realize, we really want to change that command line option. Once we put it out as a final tool, the only thing we can do is add to it. We can't change what's already there. And so we're going to give it a release or two to bake. We don't actually plan to make any changes, but this leaves us the door open to make changes. And so what we're hoping is once we put it out in JDK 14, it'll be there delivered in all OpenJDK releases, and you'll be able to run it, package applications with it. Other than a little warning when you run it, you won't even know that it's not a final tool, that it's incubating. And then we expect that in a couple of releases, we will make it final. So here are some links to be aware of. We've got the JEP pointer, as I mentioned, the early access release. We can actually take bugs at bugreport.java.com. You can file it under component tools, subcomponent jpackage. It's already there, so we're already accepting bugs from early access. And a lot of people have submitted them, and it's been very helpful. The mailing list where jpackage is discussed is corelibsdev. And the future, we're looking to, as I mentioned, moving it from incubating to final. Likely in JDK 16, because I don't know if you were here when Brian Getz talked about in the Q&A, Ask the Architects. He basically realized that for a lot of things, one release isn't enough, because really, even though the release is every 6 months, you only have 3 months from the time the previous release ships until the time you have to freeze the API and interfaces for the next release. And so we feel that giving it 9 months rather than 6 months will be a lot more comfortable. And then we have a few features that we didn't get in for the first version, and we're looking to add them in the subsequent versions. So in summary, if any of you have ever used JavaPackager, it's dead, but we think jpackage is a great replacement tool. We know there are some missing features, some of which there are a couple of them that were on that previous list that JavaPackager had, and we're really hoping to restore those. We know there are going to be some bugs, but we believe this is a very important part of the deployment story. And we need your feedback, so please download it and try it. And now I think we have about 5 minutes left for questions. So if anybody has questions, I'll take them now. Yes?
Do we have tried or package a Tomcat application?
I'm sorry, what was this?
Do you try to package a Tomcat application?
A Tomcat application? No, because we're not really doing this as an application server. We're doing it more as a bundler. So we haven't tried that at all. No, sorry. Yes?
Will it be possible to manually add via extension or something other file types it can build?
In what, like, specifically, what are you thinking about? And maybe it's possible.
Say you want to build it for OpenSUSE, and I think that...
Oh, I see what you mean. You mean if you have something other than a Debian or an RPM?
For example, yeah.
Not easily. That's something, extensibility is something that could have been on that list for maybe something we could do in the future. What you can do, though, is, that I didn't show, is you can build, at least if you're on a Debian or RPM machine, you can have it create the temporary directory that it's using for packaging if you need to go customize that, and then go customize it afterwards. So if there's something we didn't do for a Debian machine that you need, you'll be able to do that. But a brand new package type, we don't have that kind of extensibility right now.
Is that planned?
Not directly, but if it's something you'd like, I'd maybe express that on corelibs dev, and we can file an enhancement request for that.
Okay, thanks.
All right. Yes, right there.
When it comes to uninstalling, can you specify, like, additional directories that need to be cleaned up? Like, I have my application here, and then I have, like, this cache directory here.
No, that's a good question. If it's... Yeah, you can certainly specify additional, like, post-install. I'm thinking Linux now specifically. You can specify post-install, and I believe, but I'm not sure, that you can do the same with, like, a post-uninstall or pre-uninstall. I don't know how that works exactly, but that would be a good question for me to take back and find out. So again, if you could ask that on the corelibs dev list, we could get that, because that's something I could imagine would even be possible in the first version or the second version if we somehow missed that. Yes, there's a question right there.
Can I package native code for JNI?
Can you package native code for JNI? Yes, you can do that in one of two ways. If it's a non-modular app, or I guess even if it's a modular app, what you can do is specify in your input directory, you would put all of your DLLs, let's just say Windows for now, but it would apply to the other ones. Put your DLLs in there, and then you have an option to Java, your Java launcher, that would tell it where to find those DLLs. That's one way to do it. The second way to do it is, for a modular app, you could actually create a JMod file. So for example, the JavaFX program we ran, even though it's a third-party library, you could imagine an application doing the same thing. We deliver JavaFX in one of the ways as a JMod file, which contains, it's basically like a jar file with some additional stuff, and it's got directories for modules, for native libraries, and configuration files. And Jlink understands JMod files, and it will link it in with your runtime, and it'll put the DLLs in the same place that all the JVM DLLs are. So I'd probably recommend that second one, going with a modular app, because I know that one will work. The first one should work, but we haven't tried it. Any other questions? Do I see a hand up there? Yeah.
So when it comes to, you mentioned signing, is this something that jpackage can do? Like, can you specify, on the command line, please use this certificate, whatever.
So for Mac, we already do that, although what we don't do for this reason, or for this release, and should have been on the futures list, is we don't do notarization yet. but that's something we eventually will look at doing. For Windows and Linux, we don't do signing right now. For Windows, it's easy enough. If you just take the MSI file that it does and sign it yourself, we believe that will give you enough capability. But if not, let us know and we could add that in the future. But Mac, we already have. And I think we have time for maybe one more question, and then I'm out of time. All right. Well, if there aren't any, then thank you.